Kia ora, my name's Vincent from Janky Gamesmiths, and I'm going to run you through the setup and what's contained in the Janky Spline Tiler package that will soon hopefully be up on the Unity Asset Store. So just to begin, let's import the package. I've got a clean project here that I'm working on, so this will be the setup for most cases when you jump in. In the package, you're going to find all the usual bits and bobs. We've got the core componentry that comes with the package. And then I also have an example project, which is pretty much a complete game, a little kind of classic horror game that comes with it, including all of the assets that would be in said horror game. Some little example scripts there, which you might want to use in your projects or not. Yeah, so let's bring that in. Cool. Now, if you haven't installed the Unity Spline package as of yet, you just want to go to the Unity registry, type in Spline and install the Unity Spline package. Awesome. And the other package that this asset relies upon is the FBX exporter. Cool. So we're just going to install that. Excellent. And that's all good to go. So let's have a look at quick setup. So I'm going to create a spline in the scene. Wicked. And then I'm also going to add a Janky Spline Tiler to said spline. Cool. Now what the Janky Spline Tiler is composed of is a observer script. And what this is going to do is it's going to check for any changes in the spline container there, and then trigger a regeneration of your tiled spline mesh. There's a check interval. You can bring this all the way down to 0 if you want really rapid feedback, and then if you're working on incredibly complex meshes, you may only want to do a check, every second. And that will speed up your regeneration process there. And then you've also got the option to just turn off regeneration on change as well. If you're going to be doing some advanced edits, maybe on really large meshes. But yeah, there's that there. And then you've got the main Janky Spline Tiler window. So first thing I need to do to start using this is just bring in the spline container that the spline tiler is going to be focusing on. And we don't have any tiles added to this yet, so I'm just going to bring a couple through from the examples in here. So I'll use the Haunted Road main tiles. Got one in there at the moment. If I hit regenerate mesh, we'll see it pop up. Oh, that's terrible. And that might be because I made the spline a little bit too small. Cool. So there we go. We're starting to see the spline tiler in action already. Excellent. So what this has just created is a little, I guess, roadway with shonky little houses, or like a wall with roofs. Anyway, this is just part of that example pack that comes with it. But at the moment, it's not hugely interesting. So what I can do is I can include other tiles in the generation. So I'm just going to add all 4 of the tiles in there. That are available. Excellent. Now, if I hit regenerate mesh, you'll see that nothing happens. And that's because by default, the system selects from the very first tile in the array. But what I'm going to do is I'm going to chuck randomize on, and you'll see straight away that we have some variation that's now been included. So this is a quick way of getting a individual mesh that conforms to your spline with some nice variation in there. And this is just very simple variation that's been displayed, but you know, it's all down to how complex your tiles are. Excellent. Now, next thing I'm just going to do is I've got my spline selected, I've got the spline tool active, and I'm going to create a new spline. And you'll see that this system handles multiple splines in the same container. Cool. So we now have 2 splines in that spline container, and I can even go up to 3 or 4. You know, the sky's the limit, pretty much, or at least your processing power is the limit. You'll also probably notice that the regeneration does slow down a little bit, but only slightly. Yeah. Awesome. Now with randomization, we have a couple of options here. We either use complete randomization, and what I can do is I can actually change the weighting of tiles in the randomization process. So now we're going to get less of that first tile. Change that weight to 0.2 and that weight to 0.3. Awesome. There we go. And now we've got too many of these sticky uppy tiles. So I'm just going to reduce those back to their initial weights of a 1. And that's going to promote even generation across the tiles. Sweet. Then I can also use a randomization seed as well. So that means whenever I regenerate the mesh, it's always going to regenerate in the same way. So what would usually happen if you have complete randomization on is every time it regenerates, it does a re-randomization. So this time it's fixed, but if I turn it off, you'll see it all goes everywhere. And we've got random selection. Now, what we also have in here that's nice and fun is, oh, I've got my gizmos turned off. You'll see that there's these little blue circles that appear along the spline when you have tile editing engaged. And what that does is I can just click on one of these. So right click, oh, where is it? Why won't you focus? One moment. Oh, it's because I've got the spline editor on. That's my fault. There we go. Yeah, it doesn't work while the spline editor's on because the spline editor takes precedence over this the Janky Spline Tiler script. But if I turn the spline editor off, I can click on this and I can actually select the tile that I want at that particular point along the spline. And you'll see that it updates pretty much immediately. Everything else is updating, so I'll put that random seed back on for consistency. And that just lets me define exactly what I want at that particular point in the tile. And when I've selected a tile from, like via this editing, the tile editing system, that tile's position will no longer be included in the randomization process. So you'll be able to keep that tile in its same place unless the number of tiles reduces to a point where the tile is overwritten. So you'll see it stays there. Oh, I'll just turn off the editing because that can cause issues as well. You'll see it stays there consistently. Even if I turn the seed off, it should stay in its location. There we go. So that one tile there is always this. But if I make the spline so short that the tile disappears, it'll disappear from the randomization, from the tile selection process. Or I can unassign a tile override just by selecting none. So I can set it and then turn it back to none. Cool. So that's the tile selections. Now you could imagine maybe you're working with terrain or something like that, and rather than a street with houses, you've got a nice cliff face that tiles, and then you've got maybe a you've set up a specific tile that transforms the cliff face into a cave. This is a really great way of going, okay, so I want a cave at this point on my cliff. Yeah, that's pretty much that. And that's also part of the reason why I designed this package, was I just wanted more flexibility when creating spline conforming meshes, so I could create these unique opportunities in my game design and my level design that I have found difficult in the past to produce or reproduce in my work. So yeah, I brought that to you guys. What we also have here or available is you can deform with a roll. That might be good for some kind of like Tim Burton-esque freaky game scenario, but if you're doing like a, let's say, Wipeout style game and you've got a nice like futuristic road there, you know, like most spline tools, you've got the ability to get it to deform and create fun rolling characteristics along your road. Okay, yeah. In the Janky Spline Tiler as well, by default, it doesn't generate a mesh collider, but we have an option here to generate a mesh collider, and that will just add it to it. And the mesh collider, once you've added that to as a generation option, it should update in real time whenever you regenerate, which is great. We've got these weld seams option here, which is good if you're using procedural texturing, like procedural world space texturing, but it does have a tendency to mess with your UVs, as you can see here. If you've got really specifically defined UVs that you want to have captured, it'll stuff with those a little bit. I'm still working on getting this to preserve the UVs correctly, but for the time being, if you're going to use the welding tile seams, I would definitely suggest using procedural texturing methods rather than UV texturing. Anyway, I can turn that off and it returns to normal. Work good. And I've also got handle override settings here in case you want really big bulbous handles for your tile overrides. Cool. Oh, the other one that I missed was you can, if you put spline roll in, or spline roll is unintentionally ended up in your splines just by surface detection or something, when you're creating new knots in the spline, you can just override that as well, and it will just return to a flush world up coordinate system. Or actually, I think it might be container up. Let me just check that. I can't remember what I set. It's my own package, but I don't remember. Let's have a look. Yeah, it's container up. So you can change the entire container and it will preserve that container up orientation for you. Cool. Let's bring that back to 0. And I also actually don't want the that roll in there. So I'm just going to return this back to 0. Cool. And I'm going to take off the ignore spline roll as well for this next bit of the demonstration. Okay. Sorry, I've got a little bit of a croaky throat today. So there's another subsystem in this that we can use, which is pretty nice. And I'm just going to grab one of the junction type prefabs from the example. Cool. So here's a junction. And what you'll notice on the junction is that there are these little green nodes that are drawn on it. Now those are predefined points in the prefab with the Janky Spline Snapper script attached to it. And I'll just quickly show you what that does. So like the Janky Spline Tiler, it needs a spline container assigned. Cool. And then once that's assigned, I can click on select not. Boom. And I can go and select the knot from the spline that I want to attach to this tile. Now we're seeing that we're not getting a cohesive attachment here. And that happens because the spline's knot type is set to auto. It functions best when using Bezier. I think I pronounced that properly, Bezier curves. And that allows you to define your tangent length. I can just throw it wherever I want here at the moment. I do find that having a bit of a longer tangent will create a nice smooth transition into your junction. So I'm going to stretch out that tangent for all of them. Cool. And then I'm going to return to that attachment point there. And what I can do is I can just snap the attachment point. Awesome. So we're getting an orientation problem. So I'm going to change the rotation offset. Maybe it's 90. No, maybe it's 180. Yep, there we go. That worked. Because it's 180, I can degree offset. I can also use mirror on snap. Oh, it's not working in this case. Why is it not working? Oh well, that's a little bug I need to fix. But yeah, either way, you can see that I've got a nice smooth attachment between the spline mesh and that junction. And I'm just going to go through and do that for all the other ones as well. So add in the container, and then I select the tile, and that transition is orientated correctly from the get-go, which is awesome. Next one, spline container, select not. Wicked. Now, nope. So it's not 90, it'll probably be negative 90. Nope. Is this 180 again? No. Okay. This is another one of those little conundrums that you can run into every now and again. And this just means you need to do an additional rotation reorientation on the, so many big words, on the actual attachment point or the snap point itself to help you debug where this rotation issue is. There we go. So usually if you're having rotation issues like that, sometimes I find that the snapping completely flips the spline knots roll upside down unintentionally, and that just can be because the local rotation of the snap point is bugging up the snapper system. So you just need to change that local rotation and then reallocate the rotation offset or define that and re-snap the knot, and you'll find that everything becomes consistent again. Cool. Let's do this one more time. Hopefully we're not going to have any issues with this one. We got a offset. So I'm just going to iterate through. There we go. So it's -90 for that. They got it working. Awesome. So that was a little bit fiddly. I have found that during development time, you just get into the habit of doing that quick little iterative search. I tried doing automatic searching on those attachment points, but for some reason that doesn't seem to be working when you're using multiple splines in a single spline container. So I decided that for ease of use, it would just be easier to make it manual. You can totally debate me on that, but whatever. So now that that's attached, what you'll find is if you move the tile around, the spline will also track with it and regenerate in real time with it as well. And that also works with your rotations. If you remember the tangents that I pushed out in the splines, that allows for this really nice smooth bending from the tile point there. So yeah. Now, I guess the next one to go into, so this is working. We've got a little sump in a roadway set up. That's kind of cool. I kind of like that. But you know what? I actually want to make my own tiles. So thinking about it, I might wrap up here and I'll put it for brevity into another little tutorial video that will kick off from where we are at the moment in just a sec. So thank you for that. See you in the next video.